Alright, so this is a series of videos that you can use for the factoring section to review. We'll be using factoring all throughout the course, and it'll just kind of continue to build until the very end, and then you kind of just be expected to factor all the time. And so there's a procedure that I picked up along the way that for me it cuts out all of the guesswork. And so I pretty much removed all the videos that are included in my math lab because they just do the guessing technique. And you're more than welcome to go back and use those guessing techniques, or to use a previous technique that you might have learned in high school. Like some people call it the postage stamp, is a technique that they use, which is pretty much identical to what I'm going to show you today. It's just that it does in a different process. So first thing is that in factoring we have several different facets we need to consider. We have 2-term, 3-term, and 4-term. We're not going to talk about 4-term on this particular video. In this video we're going to focus on, this particular video we're going to focus on just greatest common factor, but we will have a video on 2 terms and then several videos or a video on 3 terms. So let's take a look at greatest common factor. So this is the technique we're going to use, but I just left this slide right here, and that whenever we do the process of factoring using bottoms up, we always, or anytime we factor, we always look for the greatest common factor first. So we come across these examples right here, and remember the objective of this video is greatest common factor. So we take a look at the first binomial, and we see that, all right, if we look at the 8 and the 32, we can see that we can take an 8 out of this guy and an 8 out of that guy. So when this guy is factored, this becomes 8. What's left is x plus 4. So greatest common factor. Take a look at the second guy. What does the first term and the second term have in common? So if we scan through, we can see that this guy has an x and a y, and this guy also has an x and a y. So we pull that x, y out front. That leaves us, if you want to, you can even think about it like this, like canceling. So the x's cancel, the y's cancel. That leaves us with 7. Over here, the 6 cancels. I'm sorry, the x's cancel, excuse me. And then at this point, we have 2 y's on top and 1 y on the bottom. So the y on the bottom cancels, and then that 2 cancels, meaning that, because essentially what happens is we had y squared over y, and that's really equal to y times y over y. So what happened was one of those y's canceled. So on the bottom, or on the second part, that leaves us with negative 6y. As we move along, we get more complicated, and that there's just more terms to look at, more possibilities. So we're trying to find the largest factor that each term has in common. So if I scan through here and look at the coefficients, I can see that this guy has a 3 I could take out, and then I could also take a 3 out of him. Let me move that over a little bit. I could take a 3 out of him and a 3 out of him, and this guy also has a 3 I could take out. As I look a little bit closer, I notice that all of these guys have k's in them, and as a matter of fact, the most amount of k's I have are 7. So I can take a k to the 7th out, k to the 7th out, k to the 7th out. And then can go even further, and I realize that every one of these has m's, and the largest amount of m's that they have in common are m squared. So I can take an m squared out of each one. So when I start simplifying this, I see that over here my 3's cancel, my k's cancel, and my m's cancel. So after I take out that 3, k to the 7th, m to the 2nd, I open up my parentheses, and on the first one I'm just left with a 1 because everything canceled, but I have to have that placeholder. On the second one, 9 divided by 3 is 3. I had 9 k's on top, 7 k's on the bottom. Remember, I take those exponents and subtract them, so that gives me k squared. Here I have m squared on top, m squared on the bottom, so those cancel. Minus 18 divided by 3 is 6. K7 on top, K7 on the bottom, so those cancel. and then I have m3, and I subtract those exponents, and I find out that I have 1m left on top. Alright, so greatest common factor. And then I threw this guy in here just because I wanted to kind of make sure that we saw something a little bit different. In this case here, what I wanted you to see is that a binomial can actually be a common factor. So you can see if you look at both of these terms, both terms have a common factor, and that common factor is 3x plus 2. So I can actually factor out the 3x. I'll tell you what, let's do it this way. Sorry. Let's do it like the technique I've been following, and let's show that I can take a 3x plus 2 out of this guy and a 3x plus 2 out of this guy. So when I do that, those cancel. So I take that 3x plus 2 out. I come back across, those cancel. That leaves me with a 4x minus, those cancel, 5. So what it creates is two binomials that are multiplied together. Alright, so that's a quick little video on greatest common factor. We'll split this up and we'll pause this and we'll move on to the next video for the next section.